All right, so what I plan on doing today is as we go over the homework that was due today, I want to fill in the review sheet as we go. But before we do that, I want to point out that it's a chapter 2 test. That means the stuff we did last chapter is fair game. I will, however, tell you I'm not going to include any questions about the atmosphere, lithosphere, or hydrosphere. It'll just be based on latitude and longitude, and then the maps that we were working on that kind of go along with this homework assignment. So it is a chapter 2 test, not just a chapter 2 part 1 test or 2 tests. So it's everything we've learned, but I will let you know, no atmosphere, lithosphere, or hydrosphere questions. So we're going to start here. The first thing was, what is the contour interval for this map? The first thing I want to say is, if you didn't know what some of these words meant, that's why you have your packet right there with you. A contour interval is what the lines go up by. So what do the lines go up by? How do you figure this out on this map? There's not many labels. Nobody? Yeah, the only 2 lines that are even labeled is this 500 and this 550. I had some people say, well, what about this 533? Is that a line? What is that? That's a benchmark. That's just that random spot right there that they are telling you is 533. It is not an actual line. So what the line, and then I had a bunch of people that assumed this line right here was 0. Can you just assume this line is 0? No, it would either have to count to 0 or be labeled by 0. If it's not labeled, you can't just assume it's 0 because it's the first line. The only way you could assume is if it was 0 is instead of Lake Lackawanna, this said Atlantic Ocean or Pacific Ocean. If something is at the ocean, it will have a 0 feet above sea level mark. But this isn't, so you can't. So here's 500 and here's 510. What are the lines going up by? 10. And what are these, by the way, 10 meters or 10 feet? And how do you know? If these units are given in miles, then these units are given in feet. Feet and miles go together, meters and kilometers go together. So from that question, what important facts should we put on our review sheet? Okay, I don't think we use the map. Well, I see what you're saying, the map scale. So the first important fact is that gradient, for gradient, the units are either feet per mile or meters per kilometer. Make sure you abbreviate those properly. MI for miles, M for meters. What other important facts did we get from this first question? Or something that you just need to know for the test tomorrow? We didn't use the formula for this question. Anybody? How about the definition of contour interval? Okay, so contour interval is what the lines go up by, or what they count. Let's see it like that. How they count is another way to put it. You must know what the contour interval is, and you must be able to find it. So from one little question, we have two important facts. All right, the second question is state the general compass direction for which this stream, what stream? Maple Stream is flowing. So Maple Stream is right here. They want to know what way Maple Stream is flowing. There's two ways to tell this. First of all, does anybody know the answer? South, or did anybody like adjust it a little bit? Yes, south, and you could abbreviate it just S, or southwest would have been good answers. Again, S or SW. But my question is for the review sheet. Streams flow. The follow-up question for this on the regions is usually, how do you know that Maple Stream flows south-southwest? Because what? Okay, so streams flow downhill. That's the first thing, but how would you put that in words? If the Regents literally said, how do you know Maple Stream flows down to the southwest? How can you tell that downhill from the map is this way or is southwest? Yeah. Not the gap. What were you saying, Megan? High to low elevations. So you could, and you would have to put that in words on the regions. So you could say that it's higher elevation up in the northeast, and it gets lower as you go southwest. So the river flows downhill. But there is another important fact about streams that are very important here too. What is the other way you can tell which way a stream flows? So this, guys, I think is even more important than the downhill part. The contour lines bend. Notice how they all come to a V, right? They all make like a U-ish or a V-ish shape. See how the lines are bent? They always point to where the water came from. That's one way of thinking about it. So if these V's are pointing this way to the northeast, that's where it came from. Or you can think about it as water flows out of the V's of the contour line. So here's the V, so the water is going to come out of them. That is almost more important than knowing the downhill. Water flows out of the V. Does everybody know what I mean by out of the V? Okay, do you see how these are all the lines are bending here? Can you use your imagination to see those are V's? The water's coming out of the V. So if the V is opening up this way, the water's coming out of the V. So it always comes out of the V. So if this is the V, it's going to be coming out and going this way. Okay. So you can tell on this one, on Colden Creek, the same thing. Here's the V's. So which way is the stream flowing in this case? For Colden Creek. No, it's an actual question, guys. South. So again, the V's are opening up. You can see the V's. And the water is going to come out of those V's. So the water is going to come out of the opening. Can't come out of where it's closed. It has to come out of the opening of the V. Do you have that into your review sheet? All right, question 2. Oh, right there. Question 3. Calculate the gradient. This is what we were doing all day yesterday for the most part. You can go through all the steps, or you can just plug it into the formula. It's the change divided by distance. And by the way, if you read all the words, what two letters are we doing this in between? Y and Z, guys, I have more than 2 people in my class. I need everyone participating. Here's Y, here's Z. We need to first figure out how much it changes between Y and Z. So before we figure out how much it changes, what do we need to do? How about people on this side of the room? What do you need to know before we can figure out how much it changes? No, we don't need the distance first. The difference and what do we need to know for the difference? Yeah, we need to know we need to know how much they are before we can figure out the difference. And this part was a struggle for a lot of people. And the important thing I kept going back to is the contour interval is 10. So these lines are going up by 10. We know this line right here. This line is labeled 500. So we know right here is 500. So if we're going to go up the hill this way, and we already know that this line here is 550. So we do know that this is 510, 520, 530. So this line right here is 510. So what is it right there at Z? It's 520. Going backwards, if this is 500 to get to Y, what is the elevation at Y? 490. So to figure out the change, we take 520 minus 490, and that gives us 30. So it changes 30 feet. So if you were to walk from Y to Z, you'd be going up in the air 30 feet. But the next part we need to know is the distance. So in other words, how far apart are they? So how many miles will you have to walk? Everybody, I need you off your phones. If you're not participating, you cannot be on your phone. So to figure out the distance, you mark off the Y and the Z. You don't care about the rest of them, only Y and Z. Bring that down to the scale, and you can see it is perfectly right here. There's 4, there's 6, so this must be 5 miles. So we should get 6 feet per mile. You need to include the proper units when you do this. What should we include on our review sheet now? How about somebody I haven't heard from yet? Formula. The formula, which is what, Connor? G equals change in field value. Yep. So gradient is change in field value. Now, field value is just a fancy name for change in whatever the heck you're measuring, divided by distance. I can also show you another quick trick. If you know these lines go up by 10, that means if you're here, no matter what this number is, you go 10 to get to this line, 20 to get to this line, so you just keep counting by 10s, and 30 to get to that line. So as long as you know what the lines are counting by, you don't actually have to subtract. You can just go, okay, here's 0, 10, 20, 30 feet. So you don't actually have to subtract, you can just count. Remember, this is on your ESRT page 1, in case you forget. Are you guys filling in your review sheets? Yeah. Okay, awesome. All right, describe the evidence shown that indicates the southern side of Holland Hill. So here's Holland Hill. How do we know which side is the southern side? But how do you know that? Because it's labeled on the bottom. Right here, it tells you that if you are going this way on the map, so if you're going towards the top of the paper, you're going north. Unfortunately, the regents will mess with you sometimes. So remember, my number one rule of earth science is to read all the words, including a label on a little map. They might mess with you and say sometime that north is this way. So if they say this, all that means is north is down here, eat soggy waffles. So it still goes the same way, but sometimes they'll mess with you. And they did it once on the Regents, and I'll admit, I couldn't figure out that question for probably 25 minutes. Because it messed with me. Anyway, how do we know that the southern side, this side? Yes, so how do you answer this? What evidence indicates the southern side is steepest? You simply say lines are close together. So what should we put on the review sheet? Yes. If lines are close together, the hill is steep. Just so you know, another way of saying this is it has a high gradient. If I could spell it. So if we were to actually calculate the gradient on the southern side of that hill, it would be a bigger number than if we calculated it on the northern side of the hill. That's what gradient is. It's the steepness of the hill. As long as we're over here, as long as we have this, let's say a gentle. Is it AL or EL? Anybody help me out with the word gentle? I know I should. LEL, there we go. Yeah, you're right. Gentle side is if lines are far apart. There is a gentle slope. And this means a small or low gradient. All right. Finally, the last thing that you have to be able to do with these are to do the profiles. So to make a profile, I highly recommend step one would be to label the lines. If this is 500, this is 510, this is 520, this is 530, 530, and then 520 again. 510, 510, 20, 30, 40, and then 550. I highly recommend labeling those lines on the top like that. Do you have to? No, but it's going to make your life easier when you get to this part. Mark the lines, mark all of them. 520, 530, 530, 20, 10, 10, 20, 30, 40, and 50. So I ended up just stopping writing the 5 because sometimes you can save sometimes somewhere. I won't get confused here still. Bring it down to your paper. Put the dots exactly where they belong. The 520 is already there. 30, 30, 20, 10, 10 again, 20, 30, 40, the 50 is already there. I saw a lot of you connect these incorrectly. What do I mean? So first of all, your dots needed to be like that. Then you kind of have to say, okay, I can get from 20 to 30, no problem. But then you got to think about up here at the top between the two 530s. Is that a hill or is that a valley? That's a hill. It gets higher up here. So this needs to curve up there. And then everybody had no problem connecting down to 510. Here I saw a lot of problems. The two 510s in between them. So if I come up here, I'm talking about this area right here. This whole section. Is this whole section higher or lower than 510? It is lower. And how I know that is because here's 510, here's 500. This whole section of the line is in between 500 and 510, which means there's a valley there. That you need to be able to draw those. Is that a question or a stretch?
Yeah, so would it have to go from 530 straight down to 500?
Nope, not without passing by 520 first. So if there's a 500, or if there's a 530 and it's going down, then there's a 520 and a 510, then a 500. So you can't, you would still have dots. Because you can't, there's very few places in the world that go literally straight down. They look pretty straight. Like think of the Superman roller coaster. Certainly feels like you're going straight down, but there is a slight angle. So the lines would be practically on top of each other like they are here. But there would be separate lines. So you need to be able to draw a profile. So on your reference table, need to be able to draw a profile. I don't think we have room to put all the steps. We can, yeah, sure. What's the first step? Label the lines. I'm just gonna keep it small. So label the lines with the contour interval. So label them correctly. Then what? Yep, mark and label on scrap paper. I'm gonna just go down here. So what's the third step? Put on x-axis, and step 4, make the dots. 5, connect them. 6, remember hills curve up. Valleys curve down. You need to be able to correctly draw a profile. There are several of them on the test tomorrow.
How many questions?
All my tests are always around 25, so might be a little less than 25, might be a little more than 25, but probably between 23 and 27 questions. Haven't printed it yet, so it isn't final. All right, that was 5 questions, and we've got 1, 2, 3, 4, 5, 6, 7, 8 boxes so far. Next one, make sure you can figure out the contour interval. We already did this on the review sheet. This one's super easy. Never expect one like this on a test. Never will all the lines be labeled. That's just too easy. 0, 50, 100, and 150. They are going up by 50 feet again. Again, you need to be able to tell me which way the creek is flowing. So here's the creek. And again, notice the V's. Yes, they're more like U's in this case, but the same thing, the water will come out of them. So if the water's coming out of them, it is flowing this way. So that I would have accepted south or southeast are your only choices. The profile for this one, I am not going to go through it step by step. I saw a lot of mistakes on this one though. So again, up, up, up was no problem. Curve it up at the top. Make sure you had the curve at the bottom, and again, another small curve here. The gradient. Now, one thing that was throwing people off, and it was happening on the other one too. They had you draw the profile between A and B, but then they wanted the gradient between C and D. They will mess with you like that. They will not use the same line. They will mess with you on purpose. So the difference between C and D, again, you could have done it one of two ways. You can see that C is at 50, and you could see that D is at 200. So you know the difference is 150, or if you counted by 50s, because you knew the lines went up by 50. 50, 100, 150. Either way works for me. You figure out how far apart they are. Mark them on your scrap paper. Bring it down. This one's right at 6. So it was 150 feet divided by 6 miles, gave you 25 feet per mile. You absolutely need to know how to do gradient. It's on there multiple times tomorrow. We already talked about for the top of the next page, how you figure out what the steep side is. So here's the lines that are closer together. That's in the northeast. North is not a good answer for this one because north means the whole top half. You needed to see that it's in the that right corner, so it's northeast. Figuring out the contour interval was messing with people because you saw this benchmark of 2053. That's just that number right there in the middle. It is not labeling the line. So you have to figure out what they're going up by that would get you close to that 2053. If here's 1,500, here's 1,006, 7, 8, 9, 2,000. They are going up by 100 what? Meters. I knew that because here's kilometers. Also in the direction, it does say that elevation is shown in meters. What is most likely the elevation of the two of A here? They don't label A, but we know that this is 1,600, 1,700, 1,800. So any number in between, I picked 1,750. But if you're, as long as your answer was in between 1,700 and 1,800, you're good. Again, this is meters. You need to be able to, oh, so that's actually something we should be put on here. Need to be able to estimate values in between two lines. For example, if this line is 100 and this line is 200, this dot could be approximately, would be anything between 101 and 199. As long as we're at it, I don't think I had it on the homework. Let's talk about the highest possible elevation. How do we figure out the highest possible elevation? Okay. I like how you wrote that. One number before what would have been the next line. So you go to what would be the next line and you just subtract 1. The distance between A and the 253 mark, or the 2053 mark, is 2.25 kilometers. So you need to be able to use the map scale. What's the gradient? Again, remember, gradient equals change divided by distance. And it wants it from point A to the 2053 mark. So to figure out how much it changes, it all bases on what you said A was. So you take the 2053, you subtract whatever you had for A. I picked 2050. No, I didn't. I picked 1,000. No, I didn't. 1,750. Divide that by the distance, which we just did, was 2.25. And you would have gotten, for me, I did 103 divided by 2.25, gives me 134.7. Don't leave it naked, meters per kilometer. Yep. Any questions on how I did that one? All right, to wrap this up pretty quickly, on the next one, the contour interval here is 20 meters. The highest line is 100. Oh, I did include this. So it's 180 meters. The high, and that's all it says is what is the highest contour line? 180. Here's how they change it up. What's the highest possible elevation? Yeah, so you do the 180 plus 20 would have given you the 200. You subtract 1, and that's 199 meters. So that's what we just put on the review sheet 5 seconds ago. Highest possible is 1 less than what would have been the next contour line. Distance between the two of them should be approximately 30 kilometers. It does say show your work, so we need between points A and B. We've got 180 minus 120 divided by 30 kilometers gives us 60 divided by 30, which please do not tell me is 20. It's 2 meters per kilometer. And to wrap up the last 2 questions, this one, what is the contour interval used on this map? Here's 280, skip a line, 300. Over here, we've got the 300. Now that repeats itself because it's a depression. Actually, that's something we need on the review sheet. First, depression line, spelled depression wrong. First depression line is the same as the line that came before it. The first depression line is the same as the line that came before it. So these are going up by 10. So 280, skip a line, 300. So that line that's missing is 290. I want to talk about 12. So as if you had read all the words up here, you would have read that these are representing 3-dimensional views of topographic maps above them. The elevations are measured. 12, there is a little paragraph here and you have to read it. It says a stream begins to flow downhill from D towards the depression. After a period of time, the depression fills with water. So this gets all filled up. And then it moves back downhill towards C. It says, which one of these maps shows this downhill movement? When you look at these maps, did you notice any difference?
Yeah.
You did. At first, did you? Okay, I didn't at first. I'm like, okay, 300, skip a line, or 330, 320, like they're literally numbered the exact same way. What's the only thing that's different? Yeah, the little V's. So we've got the V's in this one. They switch direction. On this one, they always point back towards D. This way, they are always pointing towards C. And here again, they both point to the depression. What do we know about the way rivers flow with the V's? Out of the V's. So if we want the water to go from D towards the depression, it's gotta be, the V's have to be which way? Okay, we want the V's, we want the water coming out of the V's, so they're gonna be flowing that way. Same here, if it's gonna come out of the depression and towards C, we need those V's pointing back towards the depression, again, that point to where they come from, or the water flows out of the V. That is answer 1. Water always flows out of the V's. So you have a test tomorrow. You need to know everything on this review sheet. And remember, you also need to know the latitude and longitude stuff from the previous chapter. Now that we've made these review sheets, I don't recommend just tucking them in your folder and never looking at them again. Tonight, I would make sure you know how to do all of the stuff on these review sheets.